Hi, welcome to another video on my Raspberry Pi 1 and wiring PI, which indicates that I'm still busy with pulse width modulation, measuring frequencies, voltage, etc. Previously I used a rather extended circuit of op amp, transistors, potmeter, number of resistors, etc. to get the pulse width modulation working on some fischertechnik motors which work on pulse width modulation. I thought that I had everything working, including this program that you see here, and I only have to start this program, give a PWM value, and I can measure some frequency. And for the fischertechnik motors, that frequency should be in a range from 40 Hz to 120 Hz on a voltage of 9. Actually between 5 and 10 volts, but nominal 9 volts. And in the extended circuit, so far I used two motors, and one had a very reduced voltage, so it barely did anything, and the other doesn't use pulse width modulation and works anyway on a voltage of 7 volts. So in order to understand why things happen the way they happen, I cut off the second motor, and I introduced a very small circuit of an LED and 1, 2 or 3 resistors of about 340 ohms or 180, and then combining them, because resistors in series add up, resistors in parallel are divided or dividing. So what I did last time as well is, with that very small circuit, measure some values, and those rose some questions about the accuracy of my voltmeter and frequency meter. Changing the program is not much use, since the library that I use for it has a maximum value of 1024, and earlier on also, let me just key in the value. So higher PWM value means a low frequency, and vice versa, low frequency or low PWM value means a high frequency. So that was something that I wondered, how can I measure resistors when they don't add up? And yes, let me tell you that when I run this program, the LED works. I quit the program and the LED goes out. So now I start the program again, and I have to give in a value, let me say 512, exactly the half, and the LED starts to burn immediately. So in that way I know that the program is working on PWM. So with all this said, let me measure a frequency, holding a probe to the minus and a probe to, that is again reminder from last time that I got confused how to exactly measure a frequency, because I have two probes with which you usually measure ohms or voltages, but in this case, or in the case of frequency with the setting to kilohertz, even using one probe already shows a frequency. In this case, when I measure at the mass, it says 4.5 kilohertz. Using the probe up another place, let's say just at the entrance of the circuit, it says nothing, and on the backside of the LED it says nothing. So let me measure another way. The mass probe on the mass and the red probe on the other side of the LED, it shows nothing, and again nothing. It starts with a value, but as soon as I connect the red probe, it goes back to absolutely nothing, and that is very strange. So let me investigate further. So now actually the interesting stuff is what is the actual resistance of these resistors, because if I measure them just like this, one probe here, one probe here, and you see on the display they're about 900 ohms. When I do it here, they're about 900 ohms. The other resistors from the same package all are 180 ohms. Let me show you. I have to do it like this, and there you go, 186 ohms. So let me just take one from here, interrupting the circuit. 187. So for some reason, obviously, the resistance measurement when they are in circuit is different, but they are quite alright. Now when I make sure that the program is not running, what is the resistance then? It is actually 187. So, and with this, it is actually 187. I start the program, given a value, 512. What happens with the resistance? And you see that is quite different. I give in another value, let's say 256. About 500 ohms. I go lower to let's say half of it, 128. And it's 355 or about that. Let's go half again. That will be 46. About 280. Let's go lower again. 32. 225. Let's go to 16. About 210. Even lower, 8. What happens now? Comes very close to 187. And then I quit the program. And there you got 187 or 8. So the conclusion is the program influences the resistance of the over the resistor. So how to deal with this? Nice question. After these results, I actually want to know if I do measure everything correctly with my multimeter, and it turns out that also the frequency is actually measured the way I have been doing it all along. So with that knowledge, I'm going to do it like this. Oops. Or try to anyway. Let's see if this holds. Just a crocodile beak with my black probe. Let me show you. Like this. And under it is a capacitor, but that doesn't matter. And then let's start the program again. Let's say start from unrolled. So I start with a pulse width modulation of 8. And let's just measure some. This is 4 kilohertz. And this is quite varying. And unfortunately, I can't use my analog multimeter since it doesn't measure frequency. Anyway, this is say 460. Let's stabilize it around 8. And this is higher and higher and higher. Once again here we say it's around 4. Around 4 because it's the same position basically, this and this position. Then we go here and we measure around 9, which is twice as high. And here also, and here we measure, let me measure it on this position. Which is 4 kilohertz. So let's go to a different value, 16. What do we measure? Here It's 10. What do we measure here? It's 9. 1 up, 32. 1 up as now double. I don't do 1 up, I do double. $64 now. Let's do 128. And that goes off. I go down 64. Alright. Now if I change my range in frequency to 200 kilohertz, what happens then if I go to 128? Ah, see, that's a difference. 256. Wow, that's quite some difference. So I had it in the wrong position, but this is reaching the 200k limit. I'm not quite sure what to think of this. But anyway, what I want to do is use a pulse width modulation motor, and with this frequency the fischertechnik motor are out of the question, because they only operate at 9 volt for 40 Hz, 120 Hz, and that is no way close to this one. So how to solve that is a good question. The example of this small circuit was about 300 ohms, and this one is around 340. So what happens if I reduce the resistance by taking one away and putting this one right here? So let's see what happens now. Let's first measure the resistance. Without the program running. That's interesting. I said without the program running, and so it does. And if I remove this, I see it is in mass, so that is correct. Right, this should be still in there. Measuring it is still not quite as nice. Let me use another one if possible. Alright, this is going. Will this work? I do hope so. Yeah, well, 188. Alright. So let's change to frequency. It's 10 kilo. This is around 10k. So what happens when I start the program, because I don't believe it's 10K at all, let's say 32, starting low again, it's 19, and somehow I don't believe that. It raises my question, how good is that library? Let's go to 128. And see, this goes off the scale. So I change to 200 kilohertz and I see it's 82 kilohertz, and I don't think that is what I want. This is not what I want at all. So should I need more resistors? Let's just do that. Putting in more resistors to see what happens. So now I should keep in mind that this is connected and this is connected, and this way it's not connected, so I should use a few of here and maybe a few here, and then connect them all. Let's use 4. So now I have put here 4 resistors and they're all interconnected to the LED, which still shines. I did not stop the program. So let's see how this works out. And this is 76. Let me go back to 32. And this is lower. And remember that originally I measured that the frequency was in reverse of the pulse width modulation. So a high pulse width modulation gave a low frequency. Now I am at 32 and I measure 23. And here I measure 21, so that doesn't matter as much. So let me go to 512. And you see it goes sky high. So there goes my theory of low frequency. And that might be caused by the number of resistors. Just might be. So what if I take one resistor out and I put this one? Alright, 3 resistors, let's see. Well, that is 151. So that goes up to the sky, 151. I put it back. I put this one back. Measuring again on the LED. Still 151. Doesn't matter. I thought it would. Let's go down. 22. Let's go up. Maximum. How can that be? I am at maximum 1024 and it says 16 point whatever. Going back 32. Alright, now I'm really puzzled. 512. How can that be? So a frequency of 512, which is mid-range, exactly mid-range, is 150 kilohertz. I go to 2 is 49. I go to 1, 51, whatever. 2 again, 49, 48. I go to 1024. So it goes up, it goes, so 512 is maximum apparently, and then you have a low frequency, but I still don't get it. I still really do not get it. I figure that I need something to search out, because I can't change the code, but I have to find out why this is happening. Anyway, for now this is it. Thank you for watching. Please, if you like my videos, consider to allow advertisements in between the segments, or visit my website to find another way to support my website, to support my blog. And please subscribe to my YouTube, follow my Twitter, see my Instagram, and this is to be continued.